Load. Come on. Okay, we're live. It says it's a bit red, but why is it so quiet? Or is it me? Probably me. It's really quiet. Whatever. Whatever. Right. What are we doing? Keyboard. What I want to see what's next. I might be able to skip ahead. Alright, let's have a look.
Go ahead and flip the recording so we will have a nice clean one for the YouTubes. Welcome everybody to Handmade Hero, the live show where we code a complete professional quality game from scratch using absolutely nothing, no libraries, no nothing, so that we can basically see how every little part of a game works. And I've said it multiple times, I'll say it again, I think it's absolutely crucial for a good programmer's education to kind of go in and just see how everything works and really understand it before you start to do things like using higher level stuff or using libraries and stuff like that. And there's just not a lot of material out there that kind of shows how to do every last little thing so that you can kind of fill in those gaps sort of as you go and become a better game programmer. And so what we're basically trying to do on this stream is build a game where we build absolutely everything. And so far it's been going.
I'll skip ahead.
When you're doing coding, there's kind of two general ways you can think about a given function, even though there always are functions in programs. If I have a function, and I will call this functional function, let's say. This is a functional function. And then I have something which is a procedural function, or whatever you want to call it. Function with side effects, let's say. Function with side effects, because side effects are typically what distinguish something functional from something.
Hey Taras, how you doing?
Not. What distinguishes two sets of functions is whether or not, into functional or non-functional, when we use that term. Basically, a functional function is one which does not modify anything other than the stuff that it is passed and that it returns. So basically, it is going to get some values which are not pointers to things. They're not references to stuff like graphs that can be crawled or any of this sort of stuff. They are actually getting in values which themselves are not sort of writable memory. And then it returns something that is the result of whatever it's going to do. So, you know, maybe it's going to do this sort of thing, right? And I am going to return that, okay? So this is an example of a functional function. It takes two things in, two things which it does not use to go modify other stuff. It returns integer, never touches any global variables. So basically, it is entirely, it is functional almost in the mathematical sense that you would think of a function in math, where it takes parameters in and it outputs a result, but nothing else changes. The state of the program does not change in any way other than the fact that this result was computed. That's it. Now, when you have something called side effects in a function, it ceases to be functional. And basically what that means is if, let's say, I did something like this, and then I had something like foo star foo, and here's my foo, right? It's got some stuff in it. Maybe it's got a pointer to a bar, and it's got an int in it, and it's got a result, and all sorts of things. And so what I typically try to do when I am programming is I do try to push towards functional when it is not prohibitive to do so. So what does that mean? It means passing things as parameters rather than using global state. It means passing things by value rather than by reference if possible, and making them so that they're not going to be changed by the function. It means limiting the access of functions to only the things that they absolutely need to use so that they're easier to understand. And I never really ever get to a point where my code is super functional. That never really happens. It's not the nature of the kind of code I tend to write. But I do try to follow those steps to sort of increase the functionalness of the program, because every little bit you do is a bug down the line, a readability plus down the line that didn't happen, whatever, you know, that sort of thing, a complexity down the line that you didn't have to deal with. And so what I like to do here is basically there's a more complex program flow thing that would happen the way that we used to do things. In our old Win32 window handler, sorry, having trouble finding it there. In our Win32 main window callback, if this were processing the keyboard messages here, right? If this were processing those keyboard messages, it would have to have a place to put them, right? It needs to store the result of those keyboard operations. And in order to do that, that means it would have to have access to the input structure. But as you can see, I can't pass that in here. I can't give it the thing that it's supposed to be operating on because Windows has defined the function prototype for this call, and there's nothing I can do to insert myself in here. So in order to basically do the plumbing necessary to get the keyboard, basically the place where the keyboard result should be written into this function would require a global variable using the local storage in the window itself, using Windows to get inside a property, for example. I would have to use something that is very much not functional at all, because it would basically be something where the state was completely implicit and you just had to know, oh hey, by the way, the main window callback just magically knows what controller to write to and it got it from this global variable and hey, don't worry about it, right? And I don't like having things like that. So I can do much better by pulling it out into a function that's under my control. Because while again it's not going to be functional at all because it's using a message queue and pulling messages off a queue, so there's nothing functional about this function for the most part. But I can make it into more of a stable functional flow control where I'm still passing the output place directly in, and it's understandable, very clearly understandable in that functional.
I think I've done most of this. Keyboard
All right.
state.
So now that we have this, we need.
I think it does. Where is my input? Is it even? Yeah, it is. Keyboard. Yep, here. Yeah, I save input and key released, so it's persisted throughout the frame. And then can pass it to keyboard input. It is global at the moment. Not sure if that's a problem. Yeah. I mean, I wonder how it's done, how Casey does it. Or I'd have to I mean, it's easy for now. It's convenient. I'll leave it as is.
To actually process our keyboard controller for real. And so what we need to do is when we actually take the new state of the keyboard controller, what we probably want to do is say that it should actually, if we look here, the way that I've got it, we basically want to preserve some of the state. We've got the ended down thing, and we have to make sure that the ended down, we have to make sure that if we don't receive any keyboard messages this frame, we are still accurately representing the state of the keyboard, which is not something we're actually doing at the moment. We always zero out the state of the controller. So if a key goes down, we'll receive a message, we'll set ended down to be correct, that we implemented. But what we didn't do is actually make sure that it would then persist to the next frame so it would still appear to be down. And so that's what we have to actually handle now. So what we want to do probably here is basically we only really want to reset the half transition count. We want to leave ended down basically the same. So what we can do that two different ways. I guess what I'll do is I'll clear the keyboard out for now, and I will just loop over these buttons real quick.
I have access to X key invented type. Button event. I think that's the mouse button. I'm not wrong. Should be a key event. Yeah, right here. Key press and release. That is. What's replay keyboard? Okay, key. Why is it click? Maybe click percent X11. Key click percent. X11 index. Yeah, that's fine. It's the Mozilla set. I forgot about that. Cut that off. Um, event.type. What is this type? X event. Blah 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 blah. What is next event? Maybe. Yeah, I think we might have a link to the event. Yeah, there we go. Key event. Uniquely identifies, for example, report graphics, expose. Yep. Well, I want to see. key, what's it? Event dot type. I think it was just here. Go back. Okay, so that's not it. Key press. It's an event. X11. Yeah. They don't have a search here. No, they don't. Is that not how you do it? Let me check. Oh, the plus goes outside. There you go. Okay, hopefully they have a list of events. The specified X event structure removes it from the queue. Queue is empty. Yeah. Send event. Okay, so X event. X key event. It's a button event. Structures for key press, key release, button press, button release. Okay, so there is no halfway. Is that what I was looking for? Half transition. a half transition. Okay, it's weird. A symbol. Oh no, I don't see it. Button release, button pressed. I think it's same for key. Yeah. Pressed, key release. Okay, moving on.
Here, I'll basically say
Okay, that one's done. I don't have a controller right now, so I can skip that. To work across, yeah, I want to check this.
So that is all I really wanted to do for that. Now, I want to also make a couple changes to the way the stick stuff is handled. And I thought about this. I was lying in bed and I was thinking, and I'm like, oh, okay. I was falling asleep, and I'm like, oh, I should really have done the stick handling a little differently. I realized there was a smarter way to do it than what I did. At least I think there is. I don't know. It's always, every time I write code, I try writing it a little differently to see if I can get a little better, and sometimes I get worse, and sometimes I don't. It's hard to say. So I always try to come up with new ideas and be like, oh, maybe let's see what happens if I try code that looks like this, and then I go and say, ah, nah, it didn't work, that was bad, or oh, there was a good thing there, I'm going to remember that and do that thing again. So what I was thinking is basically what I'd like to do is I'd like to treat for this game, I think I'd like to treat the stick as if it's always essentially a D-pad and the things are buttons, but then just have an extra piece of data that says what the average motion of the stick was, so that if you are doing...
This is like a slight difference here. Kinda makes sense. Okay, I just saved the key. I guess that's fine. No, I'm not sure. Then I process the key inside here. Process keyboard message. I don't know.
sort of motion it can be smooth on the analog side. But you can still use it, you can still look at it as if it was buttons for the purposes of like double tap. You know, like that dash thing I was talking about. Because what I realized is the min-max thing, this thing that I was proposing, is actually kind of dumb. It's way harder for the game to use that as a thing, and it's way harder for that to capture the thing that we want, as opposed to just doing something like this: average x, right, average y, for that stick position, and basically that's just only if analog is on will it get those. And I could say that this is something like that, right? Basically, what I should do is have these be defined as buttons as well. Like basically, the up, down, left, right should actually be now defined to be buttons. The should be D-pad and buttons should all essentially be treated the same. And that way, when you look for things like dash in a direction, you just look at the half transition count for the direction. And if the half transition count is 4 or whatever, or 3, I should say, you know that that's a dash. That's it. And you can sum those over time. You look at the half transition count. If you get one half transition, you look at like how many half transitions you got in, say, a quarter of a second, and that just right there, that tells you what your, you know, whether the dude dashed or not. So I think it's just smarter to do it that way. And so maybe what I'll do is I'll break these up into stick and button or something like that, right? I don't really know if it should be button. It's like I kind of want basically like I guess action, you know, like that kind of thing. There's the action and direct and move. I guess so. It's move and action. That's good. I like that. Move up, move down, move left, move right, and action up, action down, action left, action right. That seems a little bit more interesting to me. And because then that way we basically have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these. We basically just have 10 buttons now and the stick average. So hopefully that makes a little bit of sense why I wanted to do that. I know if it's a little confusing, I apologize, but it's just something I was thinking about, and I was like, that's kind of cool. I'm going to try that. And then we'll see when we go to actually make the movement of our character, which will be pretty soon. It'll probably be a couple weeks when we're actually doing movement tuning. You'll see how I use it, and hopefully that'll make a little more sense then, too, as to why I wanted to do that. I'll be able to show, like, okay, here's the code of why I think that was good. So I think that's a more interesting way to do it, and it means that basically these become no-brainers. The keyboard now gets passed through totally directly and correctly, since those were, they are essentially buttons now, right? And so there's basically like W is move up, right? A is move left, S is move down, and D is move right, right? And then these are now the...
See, I see. Actually, that makes a lot more sense. Because we don't really care about... Okay. Interesting.
The action buttons, action up, action left, action down, action right, right? And that is like, that's it. Like that just works pretty much. I don't think that we even really need to do anything else for the keyboard. The keyboard is pretty much done. And so then all we have to do is down here say, oh, okay, that changes a little bit the way that this thing is handled. Basically what we have to decide is what that threshold is for whether it's moving left, right, or up or down. I guess at first we might say that that should be just the dead zone. If you're outside the dead zone, that's a left. If you're outside, it's a right. So I think that's probably what we want to do. So basically what I would say is now we're just going to we're going to get rid of all this min-max stuff entirely. It doesn't need to be there at all anymore. We can directly set these values. So basically we can do this sort of thing. Let's see here. There we go. We can basically directly pull those sticks and stuff them into stick average X and stick.
Okay, I think I kind of understand. So I would switch, because right now this means I do need to know what the key is. What else do I have in input? Input type, key released, time. What was time again? Because how long the key was held down? Maybe. I mean, although I am quite lazy and don't see much value. I think for now this is fine. I don't see. Maybe later when it becomes a problem, I'll deal with it then. I just want to see if captured struct game button state. Where's game button state? Half transition count, ended down. Move up, move down, move left, move right. Action up, left shoulder, right shoulder. I just watched this section.
Average y, and that's fine. But the other thing what we can do then is now say that we are going to use these stick average things to determine whether there was a trigger on one of these buttons. So basically what we will do there is say, I guess we would do this. We could even make a synthetic version of, we could even just call this function, really, if we wanted to. We could say process digital buttons with fake move buttons, essentially, and then actually just full on pass. Yeah, that's not a bad idea. Let's try that. I'll say what I'm going to do in a second here. Let me just finish making this code change, because we need to actually change. These are now action buttons, like that. There we go. And basically, I think that's basically it. That looks about right. Everything's good there. Okay. And we should probably, I feel like these guys should come in here too, while we're cleaning things up. I wonder if we should go ahead and say start and back are in here as well. Back and start. So let's do that as well, since we're, it's free. This is one of the nice things about pulling out code properly, is basically you can just kind of you don't really have to do much work to start processing other stuff. So there's the start button. Oops, it's getting behind my head. Don't want to let that get too far behind my head, or you can't see what I'm doing. So there we go. All right. So let's go ahead and just throw those in there while we're at it. Seems like a good enough reason to do that. So this is stick average x and stick average y, just to get those ported. We've got action down, and now we got to clean this up. So that's fine. We will clean that up in a second. Is there anything else? The start button, oh, that's not good. Gamepad should probably just be start and back, I would assume. Is that right? Yeah. So there we are all ported, and now I can just go ahead and do the thing that I was going to say. Basically, I've already got this function written that does the processing for the button exactly the way I want to. So what I'm going to do, I think, is just go ahead and use a fake value as if we had buttons for these guys, and I'll just set that. Value to basically be whatever, to be set properly in the case where the sticks are in the position I think they should be, and not if they're not. So basically all I'll do is say, I've got this stick average x, and maybe we'll basically say, I don't know, I mean, for the purposes of doing dashes and treating it as a button, if it's more than halfway, I don't know. It's basically like we're going to have a threshold value, basically, right? And we've remapped things between 0 and 1 now. So we need a value between 0 and 1, so halfway would be 0.5, right? And what I could do is say, well, if the stick average x, right, is less than the negative threshold. So if it's negative 0.5, right, then fake move buttons is 1, otherwise it's 0, right? So it's basically, in fact, all I'm really doing is this. I'm just doing that right there. That's it. That's all I'm doing. And so I basically made a fake button bit array that's set, it's got the bottom bit set in the case where it's exceeded the threshold and otherwise it doesn't. And then I'm just going to say basically that move left, which would be stick average x, if you're moving left, and if your stick average x is negative, then you're moving to the left because negative is mapped this way and positive is mapped to the right. Basically, I think that's mostly all I wanted to do. That's it. So yeah, and then I just checked for the threshold in the opposite direction, do it for y as well. And so now I can just call that same function, which does the counting properly, and that's it. Oops, I deleted my threshold. That was a mistake. Threshold equals 0.5. And that, Reek32, that's an interesting typo. That is really all I wanted to do for the stick handling there. And it still works fine on the average. Now, of course, we still can't use the keyboard to control anything other than just the action buttons because we're only checking for analog controllers in here. And so we need to also make sure that we handle keyboard controllers. So if the controller is not analog, which is the case of the keyboard, what we probably want to do is say, all right, let's process the blue offset at least. So we'll say something like, if that controller that we're looking at here, which we know isn't analog anymore, if it's, let's say, so it's stick average. So if it's move left, then we will go ahead and subtract, something here. We'll subtract 1, let's say, and if it's move right ended down, we'll basically do that. So basically, if you're holding any of those down, we will go ahead and update it that way. All right, there we go. So there you can see now we've got our keyboard input working. Awesome. All right.
Okay, I think I understand. Well, to be fair, I only have the keyboard, so right now I've hard coded these, and I think I still have to add blue offset. Set here. Still don't use these. That's why it doesn't move either ways. Okay, I mean, these can be just replaced with that move. Huh. So this one, both blue plus, or like minus, minus green. Set. Because I think it needs to move up. Then A is left. So the S is down, so it's what is F? WASD. So B plus green. Left, down, right. Where's D? That's right. Okay, this is right. Why am I getting so confused? There is no F. Why do I need F? I can just remove the blue. I'll put this as a to-do. It's not like really urgent. Okay, so then I think that's the end of that day. Still got some time. I think I want to fix some of the old to-dos. The main one being yeah, this one. I think I've put it off for like weeks now. So I think I could either run it in a different thread or yeah, then it would have to be. Here, let's check here. Standard thread dot spawn. Let's have a look at the standard. What do they have on Async? I think I know literally nothing about threads and Zig. Threaded builds. What is test TLS? Okay, here. Thread.spawn and it takes a function. Spawns a new thread which executes function using args and returns a handle to the spawned thread. Config can be used as hints to the platform. The caller must eventually either call join to wait for the thread to finish and free its resources, or call detach to excuse the caller from calling join and have thread clean up its resources or completion. Let me check the guide thread. Does it need to be parallel or concurrent? Yes, parallel. I guess. Not really sure. These are arguments. This is the function. Interesting. There is a problem. Because this sound buffer is for a second of audio. Where's sound buffer? Here. Might have to make this smaller. Buffer size. Sample rate times channels. Yeah, so that's like 1 second. I think this no longer exists. Oh, actually, I should check. io.reader. Gotta turn that sound off. Fucking annoying. This async. Save file, write all. Back. Excuse me. io.directory. Current working directory. Create file. Okay. Save data. io.async. Version of SIG is this? 0.15. Or maybe it's capital. io dot. I need that. I think this is already released. I'm not wrong. Or maybe not. Yeah, this is the master branch. No idea. So we correct with blocking IO because immediately. Given that IO is an interface in the runtime polymorphism sense of the word, be able to create your own or use ones implemented in a third-party package, but the extended library will offer a set of implementations for solving common uses. One that maps to blocking IO operations. Oh, I mean, audio does count as blocking IO. This implementation will be present in the standard lib and is designed to generate machine code equivalent to using C. The implementation uses blocking IO syscalls, but multiplexes them over a pool of OS threads to introduce parallelism. This can be a nice stepping stone away from single-threaded blocking, but beware, it's tricky to manage blocking operations optimally. Guess I could use this, maybe. If I can find the function. I think this might not be released yet. The Zig roadmap for 2026. Okay, I don't know. I don't know how to do this. Is there a thread version key? API APIs on other OS performing I/O combined with a thread pool. Key difference is that in this implementation, OS threads will juggle multiple async tasks in the form of green threads from stack swapping on the target platform, meaning that it will not support WASM, for example. The first prototype of this implementations have previous ones because it depends on reintroducing a special function calling convention and rewriting function bodies into state machines. Don't require explicit stack to run. Can I check? iOS and like the wrong. Moving forward, Zig will rearrange its file system, networking timers, synchronization, pretty much anything I can block into a new standard IO interface. Okay, so that's for the future. Okay, so I guess we're gonna have to work with threads. Runs a new thread which executes a function using args and returns a handle to the spawn thread. Config can be used as hints to the platform for how to spawn and execute the function. The caller must eventually either call join to wait for the thread to finish and free its resources, or call detach. Where do I write? Oh dear. During render. I should reuse the same thread. If I spawn a new thread here every time, I could go out of hand pretty quickly. It's a new thread for every frame. That means, does it not run? What is context? Zig has OS threads, oh blah blah. Zig has OS threads and wait group like Golang has. Really? There are channel implementations, well, just not in the standard. Profiling the thread utilization. Okay, let's just try. Right, it's audio. Maybe not for all, just pulse audio. Maybe no. Audio server. I wonder, does it call the function at this point? Looks like it. What if I do want it to run immediately? Functions on it, consider and call it again. Not sure what this is. Run. For concurrency primitives that support both evented IO and async IO, see the respective names in the top level standard namespace. Is that an async IO? It's not that one. Right. Problem is, audio is written here. Well, actually, yeah, within the main loop. So I can't really spawn a thread in there. I mean, does it make sense? Blocking. Let's ask Cloud. Can I spawn a thread in Zig? Thread with signal. Run a blocking synchronous. Wait, typo. Run blocking functions. Here a main approach is thread pool, manual thread spawning. Oh, and you wait for all the way group to finish. No, I think that's not what I need. Six supports, async and await. Yeah, but this is no longer present. Yeah. I think the keyword's not even present anymore. Channel-based approach. I don't know. None of those seem particularly useful. Set sock numblock. I'm not sure what's the I mean, I gotta get audio working. Just right now, this is not ideal. I mean, this looks pretty cool. I like the new Async API, but unfortunately, it's not available yet. Maybe. Oh, I don't wanna. That is an Async API. Pulse audio sync. Nah, I don't want to go back to this. No, no, no. Because I don't think I got anywhere with this last time. What was the problem? I think there was issues with writing to memory that was created by Zig. maybe it was, I don't know, but yeah. But I didn't want to go in that direction. What is pole? I don't know. I don't know. See if I can find something in the documentation. Disgusting. They have net dot. Let's have a look at how they do. Connection, content, body writer. This is io.writer. Okay. Turns appointed handles the TP server. I could see to be no. I don't know. I think I might have to come back tomorrow. I'm like totally stuck. I have no idea where to go from here. For concurrency primitives that support both evented IO and async IO, see the respective names in the top level standard namespace. I don't know what that means. Sync IO. See the respective names in the top level standard namespace. Is this trying to say that I'm looking in the wrong place? Probably. Right, so I feel like I've seen this about 10 times now. Bounce align buffer, buffered. I don't know. I think I'll figure this out later. Didn't know what to do at all. But I think I do want to figure this out before I move ahead. Because it's stopping me from... Well, it's not really stopping. Let's have a look at what's on the next day. Enforcing video frame rate. Improving audio synchronization. I should... I have no idea. Alright, I think I'm going to call it a day there. Not getting anywhere. It's gonna bother me. That was quite disappointing. I thought it'd be easier.